Okie dokie. So this is what we call a gearing system, and these can get a bit complicated. So gear A is being driven by a motor, which is driving gear B, and gear B and gear C are rotating the same since they're connected to the same axle. And then gear C is driving gear D, which is usually the gearbox, or it might be directly connected to another axle. And these things can get complicated, but this is the basic idea. So we're transforming the power from A to B, C, and then to D. All right, so we got these radii, and gear A is rotating 6 pi radians per minute. So first thing we want to do is figure out how many radians gear D is rotating, and then how many revolutions per minute, and then what miles per hour is actually happening based upon the gear D's rotation. Okay, so a quick summary of what we're looking at. So the right-hand rule, right? So if we're rotating, this is so awkward, this way, which would be counterclockwise, notice that as you curl your fingers in the direction of the rotation, the thumb is going out. Whereas if we rotated clockwise, which would be this way, the thumb would be going in. All right, so counterclockwise rotation would be this way. Okay, so thumb going out. And so I'm going to put a dot in the middle, like an arrow coming out of the board. And clockwise rotation, which would be going this way. Right, so right-hand rule, curl your fingers in the direction of the rotation. Thumb's going in the board. I'm going to put a little X, like the tail of an arrow. All right, so remember righty-tighty. So when you turn the wrench to the right into the board, the bolt is going in. Lefty-loosey, when you turn to the left, when you rotate the wrench to the left, thumb is going out, you're loosening the bolt. So that's called the right-hand rule. Okay, as far as the problem goes, all right, so what we want to do is use the ratio of the radii. So bigger circle makes a smaller circle turn faster, so 4 to 1. So I'm going to multiply this by 4 over 1. And now the 12-inch circle and the 4-inch circle. So bigger circle makes the smaller circle turn faster. 12 to 4 is the ratio. So we get that. And that's 4 times 3. So 12 times faster. So the circle D is going 12 times faster than circle A. So this gearing system is enabling 12 times more power on the D gear. Now we want revolutions per minute. Okay, we could have converted this to revolutions per minute. So every 2 pi radians is 1 rev. So this is actually 3 revolutions per minute. You could also do that here. Every 2 pi is worth 1 revolution, divide by 2 pi. And then this is going to become 3 times 12 revolutions per minute. So 36. Okay, so this circle D is turning 36 times per minute. That means 36 circumferences. Okay, so that's the next thing we want to do is we want to set up the way to get to miles per hour. Now our units are in inches. So when we do the 36 circumferences, that's going to be inches per minute. Okay, and so we're going to go from inches per minute, And then depending on how you set this up, I'll just convert the minutes to hours, and then convert the inches to feet, and then convert the feet to miles. All right, and then here we would multiply the circumference, which is 2 pi 4, and then that'll be the inches per minute, and then you can just finish the problem doing your conversion. And your miles per hour should be less than 1. So when you get your result, your miles per hour should be less than 1. It's going to be less than 1, greater than 0. So okay, so I'll wait a moment, let you guys get some time to finish that. We're going to start trigonometry today. How about that? Just a little piece of it, and we'll move into what's going to be the rest of chapter 6, which is where we're at right now.